Question 618. Evaluate the integral. We're going to apply integration technique called U substitution. And the key is that all of this expression here must be written in terms of U. Especially when two polynomials are multiplied, the polynomial with the larger exponent is usually set as U. So we're going to let U is equal to x squared plus 5. Now we have to differentiate this equation to find du. So derivative of this is du over dx. That is equal to 2x, right? So du can be written as 2x times dx. So far so good. So this integral is equal to integral x times, all of this expression is u now, right? So u to the 6 times dx. In order to have du, we must have a 2x times dx. But here we have x times dx. So all we need for du is equal to, right? So we're going to multiply by 2 here. And we must divide by 2 also. So far so good. So that is equal to 1/2 integral. Here 2x dx, that's du. And here we have u to the power of 6. So u to the 6 du, right? Now this integral is in terms of u, and antiderivative of that is, using the formula, we have to add 1. So u to the 7 over 7, right? Since this is indefinite integral, we have to add c here, right? So that is equal to 1 over 14. U was originally x squared plus 5. So substitute x squared plus 5 for u, right? So 1 over 14 times x squared plus 5 to the 7 plus c, that's our answer for this integral right here, right? Question 627. For this indefinite integral, we're going to let u is equal to square root of x, which is equal to x to the power of 1/2. Then our derivative, du over dx, is equal to 1/2 x to the negative 1/2, right? This can be written as 1 over 2 square root of x. So du is equal to 1 over 2 square root of x dx, right? Here we have 1 over square root of x already, right? So we're going to divide it by 2 and multiply by 2. Let's rewrite this indefinite integral. So integral, that's cosine square root of x, that's u, right? Times, we have 1 over square root of x dx, right? So we're going to multiply 2 here and multiply by 2 here, right? So that is equal to 2 times integral cosine u. Here, 1 over 2 square root of x dx. All of this expression is equal to du, right? So du. Now we have indefinite integral in terms of u. So that is equal to 2 times antiderivative of cosine is sine, right? So derivative of sine is equal to cosine. Sine u plus c. So far so good. So that is equal to 2 times sine u. U was originally square root of x, right? So 2 times sine square root of x plus c. That's our answer. Question 630. Here we have indefinite integral in fraction form, and if the numerator has more than one term, in this case we have 2 terms, right? Then this expression always can be separated. So we're going to separate this fraction right here as x over x squared plus 1 dx plus integral 4 over x squared plus 1 dx. Now what we can do is we can find the antiderivative of this expression and antiderivative of this expression separately. Alright? Okay, let's do that. For the first indefinite integral, we're going to have to use substitution technique, right? So we're going to let u is equal to x squared plus 1. And if we differentiate this equation, du over dx is equal to 2x. Or we can write du is equal to 2x times dx, right? So we're going to multiply by 2 here so that we'll have a 2x dx, which is equal to du and divided by 2, right? So let's rewrite this indefinite integral. 1/2 times integral. Here, denominator is u, 2x dx. Here, 2x dx. That's du, right? So 1 times du. So far, so good? Now, the second indefinite integral can be written as 4 times integral 1 over x squared plus 1 dx, right? Now, let's find the antiderivative of each indefinite integral. So, that is equal to 1/2 integral 1 over u du. That's natural log u, right? Because the derivative of natural log u is equal to 1 over u. Plus 4 times, we have integral 1 over x squared plus 1. That's the derivative of inverse tangent x, right? Remember? So that's inverse tangent x, because the derivative of this is equal to 1 over x squared plus 1, right? So we have to add c. And remember, u was originally equal to x squared plus 1, right? So that is equal to 1/2 times natural log x squared plus 1. Since this is always positive, we don't have to use the absolute value anymore, right? So plus 4 inverse tangent x plus c. That's our answer. Question 645. This time, we have a definite integral with the trigonometry expressions. First, we're going to let u is equal to cosine x. Then our derivative, du over dx is equal to negative sine. So du is equal to negative sine x times dx, right? This is a definite integral. We have lower limit 0, upper limit pi over 2, right? So x is from 0 to pi over 2. We are converting this definite integral in terms of u, right? So integral lower limit here, upper limit here, and the expression here will be in terms of u. Then our lower limit must be u value now. Okay, upper limit must be u value. Okay, so when x is 0, we have to find u. U is cosine x, right? So cosine 0, that is equal to 1. When x is pi over 2, our u is cosine x, so cosine pi over 2, cosine pi over 2 is 0, right? So when x is 0, u is equal to 1. When x is pi over 2, u is equal to 0, right? Now let's write the expression integrand in terms of u. Cosine squared, that's u squared, right? We had a sine x dx, so we're gonna multiply by -1 here and -1 here. That gives us negative integral 1 to 0 u squared here, negative sine x dx. That's our du, right? So du. Okay, now we're going to switch these two numbers. Okay, so that is equal to integral. If we switch these two numbers, then we must have a negative, right? Since we have a one negative here, that's going to be positive 0 to 1 u squared du, right? Now let's find the antiderivative of u squared. That's just the u cubed over 3, right? Lower limit 0, upper limit 1. So 1 over 3 times, substitute 1 for u, that's 1 to the power over 3, minus substitute 0, 0 to the power over 3. So that is equal to 1 over 3. Okay? Question 656. If the substitution x is equal to tangent u is made, this definite integral can be written as which of the following definite integrals? Okay, x is equal to tangent u, and we're going to have to find du, right? So let's differentiate this equation with respect to u. So dx over du is equal to the derivative of tangent, that's the secant square, right? So dx is equal to secant square u times du, right? So this definite integral is equal to, here we have lower limit 0 and upper limit 1, right? These x values must be converted to u values, right? So when x is equal to 0, we have a 0 is equal to tangent u. Tangent of what angle is equal to 0? 0, right? So we know that u is equal to 0. When x is equal to 1, we have 1 is equal to tangent to u. And tangent of what angle gives us 1? The angle pi over 4, right? Tangent of a pi over 4 is equal to 1. So our lower limit is 0, upper limit is pi over 4, right? We have square root of 1 plus x squared. 1 plus x squared is equal to 1 plus x is tangent to u. So tangent square u, right? 1 plus tangent square, that's secant square, right? That is equal to secant square u. So far so good. So we have square roots 1 plus x squared, that's secant square u. Secant square u times dx. dx is secant square u du. Secant square u du, right? So that is equal to, integral 0 to pi over 4. Here, secant square, but we have a square root. So all of this expression is just the secant u, right? So secant u times the secant square u, that's going to be secant cube, right? So the answer must be, all right? Question 658. If the function g is continuous and this definite integral is equal to 4, then what is the value of this definite integral? Okay, here we have g of x, and down here we have g of 4 minus x, right? So we're going to let u is equal to 4 minus x. Then our derivative of u, du, is equal to, well, du over dx is equal to negative 1, right? So du is negative dx, right? So this definite integral can be changed as integral g of u. We have dx here, but here we're going to multiply by negative 1 here, negative 1 here. Okay, then this is going to be du, right? Since negative dx is equal to du. So far so good. Here we have a lower limit 1. X is from 1 to upper limit x is equal to 3, right? So when x is equal to 1, our u is 4 minus x, 4 minus 1, which is equal to 3, right? So our u here is 3. When x is 3, our u is 4 minus x, 4 minus 3, which is equal to 1, right? So 1 here. Upper limit of u is equal to 1. Okay? So that is equal to negative integral from 3 to 1 g of u negative dx, that's du, right? So if we switch these two numbers, then that's going to be negative times negative. So positive integral 1 to 3 g of u du, right? Here, since integral from 1 to 3 g of x dx is equal to 4, integral from 1 to 3, same lower limit and upper limit, right? Same function right here. So that's going to be equal to 4. Okay, so the answer is 4.